Okay, Bismillahirrahmanirrahim. Okay, so I hope that all of you in a good condition and are ready to learn about topic 4. That is decision 3. Okay, decision 3. This topic quite not so challenging, but you need to know how to calculate the root. Okay, the root of a tree and etc. and etc. Okay, first of all, I will share with you. Okay, nampak tak ini? Boleh nampak tak? Nampak Kalau saya buat macam ni, nampak tak semua? Sebab saya ni. Nampak Okay. So, topic 4, decision 3, ITS665, data mining. Okay. Objective of this topic is to introduce the classification concept and its general approach. To understand technique of this decision tree, in order you have to know how to apply parameter in the decision tree using IG, information gain ratio, Gini index, and etc. And summary. So if you look at the objective, it's quite a little bit, but a lot of things that you need to understand. Okay, so okay, classification. As we know, method of classification, we have a decision tree induction, we have a bias classification method, neural networks, KNN, rule-based classification, and etc. There are a lot of classification method, but in this topic, we will cover decision tree first, and then maybe you will learn about bias classification method, neural network, KNN, rule-based classification lah. Okay. So classification methods. Okay, given a collection of record. Okay, this is a training set. As you know, when you want to run a model, okay, so you have you collect the data. For example, you have 100 data, okay, by using K-fold. Okay, K-fold is one of the approach. You use K-fold approach to separate the data. Okay, for example, K equals to 5. So you fold the data or you divide the data into 5 set. Okay, so maybe data 1, K1, K2, K3, K4, you will put it in a training set, and K5 is a validation set. Okay, to validate your model. So in that kind of data, you need to know how to train, and you need to validate your model. Okay, given a collection of record as a training set, each record contains a set of attributes. Okay, as we all know, one of the attributes is the class. Okay, I hope that you are still remember what I taught in the class, what is attribute and what is class, etc., etc. And then find a model for class attribute as a function of the value of other attribute. Okay, so you need to find a model for class attribute as a function for the value of other attribute. The goal of this classification method, previously unseen records should be assigned a class as accurately as possible. So maybe after you are doing this 100 data, and then you collect some more, maybe you collect 20 more data. So if the model is quite accurate, so you can use the model, and then you will use the model to find the class of the new data. Okay, a test set is used to determine the accuracy of the model. Usually the given data set is divided into training set and test set. With training set used to build the model, and test set used to validate it. Okay, and as I mentioned earlier. Okay, So you need to know the model. You need to divide the data into training set and also test set. Okay. So okay, for example, this is a training set. As you can see, ID 1 until 10 is a training set. Okay. By using induction, you use 3 induction algorithm, and then this algorithm will produce a model. Okay, we will learn the model. Okay, from the training set. Okay, you will learn the model, and then it will give an output of the model. Okay, so this model will be applied to the test set. Okay, as we know, it called deduction. Okay, induction and also deduction. Okay, so the test set is from ID 1 until ID 11 until ID 15. Okay, but you didn't know the class of this ID, right? So we use this model to identify the class of the test set. Okay, so I hope you understand. Okay, in supervised versus unsupervised learning, what is supervised and what is unsupervised learning? As you know, supervised learning, or we call it as a classification. Supervision, the training data, it can be an observation, measurement, and etc. are accompanied by labels, that is output indicating the class of the observation. New data is classified based on the training set. That is a supervised learning. So for unsupervised learning, we call it as a clustering. Okay, so you can after this you will familiar about this word classification, clustering. Okay, so the clustering, the label class of training data is unknown. Okay, you didn't know the class label. Given a set of measurement, observation, etc., with the aim of establishing the existence of class or clusters in the data. So as I mentioned earlier, you also can see the KD nuggets there, the link there. I think it will give some more information. It gives information about, okay, let me check first. If I'm not mistaken, okay, it will give an information about the top 10 algorithm and methods used by data scientists. Okay, so we have a regression, clustering, decision tree rules, visualization, k-nearest neighbor, KNN, PCA, statistic, random forest, time series or time sequence, and text mining. Okay, and also the second link will give you information about top 10 data mining algorithm. Okay. Okay, so supervised and unsupervised have these two type of character. There is a continuous and also categorical. In continuous, we use linear regression in supervised, and polynomial regression in supervised, and also we use a prediction by using the decision tree, DT, or random forest. Okay, unsupervised is a clustering, so use a k-means clustering or Diana. Okay, you can Google what is meant by Diana. In categorical type, we have classification for supervised. Classification use decision tree, k-nearest neighbor, logistic regression, naive Bayes, SVM, support vector machine. Unsupervised, we use association analysis. There is a priori, FP growth, and also hidden Markov model. Okay, I'm not sure you will learn about all this kind of algorithm or not, but decision tree, yes, you will learn this kind of algorithm. Okay, so decision tree is under categorical and supervised. supervised, categorical. So the classification, the tree that we will learn. Okay, example of classification task: predicting tumor cells as benign or malignant. Okay, so you want to predict tumor cells. Is it a benign or malignant? Okay, or you want to classify credit card transaction either legitimate or fraudulent. You want to classify secondary structure of protein. Is it alpha helix, beta sheet, or random coil? Categorizing news stories as finance, weather, entertainment, sport, and etc. For example, in categorizing news, okay, you got the data about news. Okay, the news show you about the sunny. Maybe the environment is sunny. And then it will give you Darjah Celsius or Fahrenheit. Okay, so it will categorize it under weather. Okay, in the sports, maybe it will give you for example, football. Okay, scoreboard, and etc. So you know that it's under sports category. Okay. Okay, application one, direct marketing. So the goal for direct marketing to reduce cost of mailing by targeting a set of consumers likely to buy a new cell phone product. Okay, for example, in a company, so you got data from the company. So all this company use Android. Company A use Android. A lot of Android. We have maybe Samsung. We have Oppo, for example. Okay. So we know that this company, the environment in that company use Android friendly user. So we target to sell Android phone to that company. Okay. Then the second company, maybe second company from top manager, top management until the lower management, they are all use iPhone. For example, iPhone 6, 7, 8, 9, 10. So you will know that this company is iPhone friendly, iPhone user friendly. So you will sell your product or iPhone product into that company. Okay, that's why you can reduce cost of mailing by targeting a set of consumer likely to buy new cell phone product. So you know the target user. Okay, approach. Okay, firstly, you use the data for a similar product introduced before. We know which customer decided to buy and which decided otherwise. This buy and don't buy. Okay, that's we call as a class attribute. Okay, this buy and don't buy. Okay, collect various demographic, lifestyle, and company interaction related information about all such customers. For example, the type of business, where they stay, how much they earn, and etc. Maybe you can say that in that company, it's a 50-50. Okay, they use iPhone. 50% of them are using iPhone, and 50% of them are using Android. So you go deeper, maybe in the surrounding, where they stay. Okay, their address. So all the neighbor are using iPhone, for example. So by doing that, you know that if you sell iPhone to that person, surely he or she will buy because of the environment of it. So we look deeper and deeper. Okay. And then we use this information as input attributes to learn a classifier model. Okay, that is for application 1 for direct marketing. For application 2, fraud detection. Okay, the goal for fraud detection is to predict fraudulent cases in credit card transaction. Okay, as you know, we want to predict whether it's a fraudulent or not. Okay. Approach use credit card transaction and the information on its account holder as attributes. When does a customer buy? For example, what does he buy? How often he pays on time, etc. and etc. And then labels past transaction as fraud or fair transactions. This forms the class attribute. So it will form a class fraud or fair. Okay. Learn a model for the class of the transaction, and we can use this model to detect fraud by observing credit card transaction on an account. Okay, Syahmi. Okay. Okay, prediction problems. Problems in prediction, classification versus numeric prediction. In classification, we predict categorical class label, either discrete or nominal, classifies data, construct a model based on the training set and the value, that is a class level, in the classifying attribute and use it in classifying new data. In a numeric prediction, the model continuous value function, for example, predicts unknown or missing value. So this is the prediction problems. Okay. Classification method. The goal is to discover rules that define whether an item belongs to a particular subset or class of data. Okay, so we want to know that item. Okay, for example, in your study, you want to define whether is it a virus or is it a what we call, maybe kita panggil apa, selain daripada virus, apa lagi selain daripada virus, maybe itu adalah parasite. Okay, so you want to categorize it. So this is the goal of classification method. Okay, two-step process: model building and prediction classification. For example, if we are trying to determine which household will respond to a direct mail campaign, this example is using a direct mail campaign, we will want rules that separates the probables from the not probables. Okay, this means that we want to know the probability this user will buy and the probability that this user will not buy. Okay, a classification model can be constructed that maps the various customer attributes. For example, age, gender, income. Okay, this we call it as a demographic information. Okay, with various product purchases. For example, luxury automobiles, ticket, clothing, etc. These if-then rules often are portrayed in a tree-like structure. Okay, so it will portray in a tree-like structure. Okay, a two-step process. Model construction describing a set of predetermined class. Firstly, each tuple or sample is assumed to belong to a predefined class as determined by the class label attribute. The set of tuples used for model construction is training set. Okay, so as I mentioned earlier, if you want to use this for construct a model, we call it as a training set. The model is represented as classification rules, decision tree, or mathematical formula. Okay, model usage for classifying future or unknown object. Estimate accuracy of the model. Okay, you can estimate accuracy of the model. The known label of test sample is compared with the classified result from the model. Accuracy rate is the percentage of test set samples that are correctly classified by the model. Okay, so we will know that either is it accurate or not. Test set is independent of training set, otherwise it will be overfitting. Okay, so when you want to use a training set and test set, the training set cannot be used for test set. Okay, so for example, we have 5 set. Okay, we have data 100, so we divide by 5. So we have a 5 group of data. Group 1, group 2, group 3, group 4, we will use as a training set. And group 5, we will use as a test set. So this training set cannot be used for test set. Otherwise, it will be overfitting. Okay. If the accuracy is acceptable, use the model to classify that data tuples whose class label are not known. Okay. So process 1, model construction. Okay, we have a training data here. ID 1 until ID 6. Okay, we test, we train the model. Okay, we use a classification algorithm. Okay, so we will construct a model, and then it will give a classification rules. Okay, if refund equals to no and marital status equals to merit, so cheat will be no. Okay, so as you can see, when refund no, okay, and then the marital status is merit, the result cheat no. Okay, so the example number 6, ID number 6, no, merit, so the result will be no. Okay, this is a classification rules, if then. Okay, earlier we talk about if then rules, right? So this is a if then. Okay, using the model in classification. Okay, testing data is used to estimate the accuracy of the classification rules. We want to estimate the accuracy. Idea this model is accurate or not. Okay, so by using a testing data, we use in the model classifier, and then we will give unseen data. We will give a new ID, no refund, merit, and ATK. So this person will cheat or not. Okay. Okay, using the model and prediction, the accuracy of a classifier on the given test is the percentage of test set tuples that are correctly classified by the classifier. Okay, if you want to measure accuracy, equals to correct number of samples, the correct number of samples, divided by total number of samples. For example, you have 100 samples, okay, and then the correct samples of data maybe 80%, 80, okay, 80. So 80 divided by 100, okay, it will become 0.8. Okay, so we know that 80% of this data is correct, so it's quite accurate. Okay, the associated class label of each test tuple is compared with the learned classifier class prediction for that tuple. Okay, example of a decision tree, categorical. Okay, we have a categorical and also continuous. So categorical, we have a refine, yes. Okay, no, yes and no. Data will show you idea is a yes or no. Marital status, single, married, divorce, okay, and then taxable income, okay, and then it will give a class, okay. For as you can see, in the box, it's a training data, and the right hand side is a model for decision tree. So we know that if refund equals to no, refund equals to yes. For example, refund equals to yes. So we see that refund for ID 1, yes, cheat no, okay. ID 4, yes, cheat no, okay. ID 7, yes, cheat no, okay. So we know that the data associate when the refund is yes, so the data is associated with the no answer. So we can conclude that if refund is yes, then the cheat is no. Okay. So what if the refund is no? So when you see the refund is no, we have a lot of some more class. Okay. Because of no in the number 2. Okay. Data number 3 no. Cheat no. Data number 5 no, but the cheat is yes. So you have 2 class in that. That's why you need to segregate, or you need to divide it, okay, by take a look at the marital status. So that's why we say that as a decision tree. Okay, you want to decide either this person will cheat or not cheat. Okay, so by using this decision tree. Okay, there could be more than one tree that fits the same data. So, for example, the root for this is a refund. So, refund will be the root, okay? And then marital status will be the leave, and also the root for the tax income. So, but the first root is refund, okay? But if you see the second one, we use as a marital status as a root. That's why I say that there could be more than one tree that fits the same data. Okay. So if you want to, if you want to apply model to test the data, start from the root of 3, refund. Okay, refund equals to no. Okay, no. So it will goes to marital status. So we see that married, so we go to married, and then, so for sure, because of refund, no, but marital status is married, so it associate the answer or it will assign the cheat into no. Okay. Okay. Decision tree induction. This is for introduction for decision tree induction. Late 70s and 80s, J. Rose Quinlan developed decision tree algorithm they call ID3, iterative dichotomizer, and then it's expanded to C4.5, CART. Decision tree induction is the learning of decision tree from class label learning tuples. Okay, so if you notice, a lot of what we call words of tuples appear. Okay, so I want you to know that tuples actually is a row. Okay, when you have a data set, you have 100 data set. Okay, so we say that this is a column. Column will be an attribute. So the tuples is a row. Okay, row. So you will find a lot of this word. Okay, tuples. A decision tree is a flowchart-like tree structure where each internal node or non-leaf node denotes a test on attribute. Each branch represents an outcome of the test, and each leaf node holds a class label. Okay, the topmost node in tree is the root node. Okay, so as we can see, algorithm here. Okay. Okay, so algorithm for decision tree induction, we have a basic algorithm, or we call it as a greedy algorithm. Tree is constructed in a top-down recursive divide and conquer manner. At start, all the training examples are at the root. Attributes are categorical. Okay, so if continuous value, they are discretized in advance. Okay, so attributes are categorical. As we see earlier, we have a categorical data. Examples are partitioned recursively based on selected attributes. Test attributes are selected based on basis of a heuristic or statistical measure, for example, information gain. Okay, condition for stopping partitioning. What is the condition that we want to stop the partition? All samples for a given node belongs to the same class. There are no remaining attributes for further partition. So we will imply majority voting. Okay, and then there are no samples left. Okay, so is it a greedy strategy? This greedy strategy split the record based on an attribute test that optimize certain criterion. Okay, next. Okay, this is so you can see how to do decision tree. Okay, you can learn it after this. Okay, general structure of Hans algorithm. Okay, let DT be the set of training records that reach a node T. General procedure. Okay, in the general procedure, if DT contains record that belongs to the same class YT, then T is a leaf node labeled as YT. If DT is an empty set, then T is a leaf node labeled by the default class. Okay, or we call it YD. If DT contains record that belongs to more than one class, we use an attribute test to split the data into smaller subset, recursively applied to the procedure to each subset. So for Hans algorithm, you can find a lot more in the YouTube. What is meant by Hans algorithm and how Hans algorithm working. Okay. So initial tree contains a single node with class label equal to node. Tree needs to be refined since the root node contains record from both class. Next tree is constructed by assigning attribute 1 as the new root. The records are divided into smaller subsets based on the outcomes of test condition attributes selection method. By using an attribute selection method, check each child with the record whether it has both class or not, and then we will repeat until all records belong to the same class. So this is a Hans algorithm. Okay, if you want to know about Hans algorithm, some more about Hans algorithm, you can always Google Hans algorithm in the YouTube, and then it will show you the method of Hans algorithm. Okay. So for example, this is the example of Hans algorithm. Okay. Okay, next, decision tree induction. Okay, design issues of decision tree induction. How to determine the data when we want to split the records. So determine how to split the record. Macam mana kita nak split the record tu? Kat mana? Siapa yang akan jadi? Which one will be root node? Dan juga which one will be leaf node? Okay. How to specify the attribute test condition to divide the record into smaller subset? How to determine the best split? Okay. Determine when to stop splitting. All records belong to the same class or all the records have identical attribute values. Possible partitioning scenario depends on attribute types. Okay, we have a nominal, ordinal, and continuous. This is our attribute types. Depend on the number of ways to split. Okay, we have a two-way split and multi-way split. What's mean by two-way split and multi-way split? Okay, this is a multi-way split. Use as many partition as listing value. So we have, for example, car type. So car type, we have a family car type, we have a sport car type, we have a luxury car type. Maybe we have MPV car type, and etc. etc. Can be more than 3. Okay, it can be 4, 5, 6. Okay, but in the binary split, divide value into 2 subsets. Need to find optimal partitioning. For example, car type. When we use a binary split, we will have only 2. We have, for example, sports and luxury in one group, and then family in one group, or family luxury in one group, sports in one group. Okay. Splitting based on ordinal attributes. Okay, so if you use ordinal, as you know, it's based on the root word order. Okay, order. So when we use a word order, so we know that because of the we can determine the order of the attributes. For example, the size, small, medium, large. Okay, so by using binary split, as you can see, size it can be categorized into small and medium, and also one more is large. Or we can be, or it can be medium and large in one group, and then small group in the one group. Okay, so there is an example. Splitting based on continuous attribute, different ways of handling. Okay, discretization to form an ordinal categorical attributes, static, discrete ones at beginning. Dynamic range can be found by equal interval bucketing, equal frequency bucketing, okay, percentile or clustering. For binary division, as you can see there, okay, we have this is only example. Okay, I will give you some more information about this topic in the WhatsApp group, so you don't have to worry at all. Okay. And then how to determine the best split. Okay, how to determine the best split. So I will give you additional link for YouTube, then you can learn how to determine the best split. Okay, by using a greedy approach, notes with homogeneous majority class distribution are preferred. Need measure to note impurity. Okay, the smaller the degree of impurity, the more skewed the class distribution. This is the example only. Okay, steps in determining the split. Okay, firstly, okay, we want to determine the split. Calculate impurity measure for different attribute as the node. Okay, use info D, info AD, or we call it as an entropy or Gini, to test how well a test condition performs. Compare the degree of impurity of the parent nodes before splitting with the degree of impurity of the child node after splitting. Okay, we use again A. The larger the difference, the better test condition. As you can see, maximizing the gain is equivalent to minimizing the weight average impurity measure of the child node. Okay, we will learn about this. Attribute selection measure, information gain. Okay, as you can see there, there is a mathematical formula. Okay, so select the attribute with the highest information gain. Let P1 be the probability that an arbitrary tuples in D belongs to class C. Estimate by CID. Okay, divide by D. So it will give you an absolute value here because we have we call it as a, I forget that word. Okay, so when you see this kind of tanda, so you will know that it's an absolute value. Expected information, entropy needs to classify a tuple in D. So this is the mathematical formula for information of D. Okay, information needed after using A to split D into V partitions to classify D. So this is the second mathematical formula. Information gained by branching on attribute A. Okay, so what's mean by that? You will know. Okay, for example, attribute selection by using information gain. We have class P, buys computer, class N, not by computer. Okay, so the class is yes or no. Class P buys computer, and class N didn't buy a computer. So okay, information of D, as you can see there in the box, we have information of D equals to I 9 5. Okay, so this is the formula, the earlier formula. If you can refer to this formula. Okay, so this is the earlier formula. We have 14 data. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have 14 data. Okay, so as you can see, 9 is percentage of people who are by the computer. Okay, so we know that this is buying data. So 9 over 14 log 2, okay, 9 over 14 minus, okay, this one is the person or the data that they didn't buy. 5% don't buy this computer. Okay, so minus 5 over 14 log 2, 5 over 14. So we put it negative in front here because we want the answer as a positive. Okay, so it will become 0.940. Okay. Okay, what about information of information, for example, information of age. Okay, we want to know or to determine which one from this age, income, student, credit rating will become the root node. So that's why we use this calculation. Okay, so for example, information of A, okay, example number 2, information of age. Okay, so from the 14 data, we extract the data into in the age data. Okay, so that's why we have in the green box here, we have a youth, middle and senior. Because of the age attribute, we have youth, middle, and also senior only. Okay, so P1, what is P1? P1 is the percentage that they buy. Okay, so we know that P, because of P here, as you can see, class P is a buy a computer. Yes, and then N is class N, so it's class that they didn't buy. So IPN is information of buy over don't buy. Okay, so we want to know the information of age. Okay, 5 over 14. Okay, why 5 over 14? Because of we know, okay, this type we will use the second formula. Okay, don't confuse the first formula and also the second formula. Okay, the first formula is to expect the information or entropy needs to classify tuple in D. It means the entropy, what is the entropy? Entropy is a measure of disorder in dataset. Okay, so it's mean by information gain. Information gain is a measure of the decrease in disorder to achieve by partitioning the original dataset. So we want to partition the dataset. So that's why we want to determine who will be the root node and who will be the leaf node, and etc. etc. Okay, so we use the second formula. Okay, here information of age, the 5 over 14. Why 5? Because youth we have 5, buy and not buy we have 5 over 14. Okay, so if you calculate, you will get this data 0.694. Okay, 5 over 14, I to 3 means the age less than or equals to 30 has 5 out of 14 samples with 2 yes and 3 no. Okay, hence that's we want to have information of age. So we want to gain the information gain for the age. So we will know that info D minus info of age, so it will become 0.246. So as we know, this information, the first information D, 0.94, 0.940. Okay, and then minus, for example, information of D, we have a 0.694. So 0.249. Okay, information of the gain for H is 0.249. Okay, so when we calculate, we know that the gain of income, for the income 0.029, gain for student 0.151, the gain for credit rating is 0.049. So which is the highest one? For sure is a H. Okay, H is the highest one. And then the second one is student. The third one is credit rating. Okay, and then the fourth one is income. So we will know that the H will become a root. Okay, H is the highest information gain, so it is selected as a splitting attribute, not N. Okay, that's mean by H will become a root. Okay, for example, so you can see here, information for the age. So I need you to calculate this, okay, and submit to me through Google Classroom. So this is the homework that you need to know. Okay, I will teach you about how to find answer for log 2 5/14, for example. Okay, so if you want to find log 2 5/14, first thing first, okay, by using this calculator, or any calculator that has a log, so you just press log, log, and then for example, we want to know log 2 5/14. So log 2 5/14. Okay, I think you can see here. Okay, and then you press equals to, it will give you negative 0.447. Okay, so this answer, okay, you need to divide by log 2. So this is the actual answer for log 2 5/14. Okay, so I think you can know about that. Okay, and then okay, this also you need to find a gain for income. You need to find a gain for income. So we have a calculation here. So you need to do it as your homework, and you need to submit to me through Google Form. Same with the student and also credit rating. Okay. So okay. For example, actually, okay, it's like this. Because of age have the highest value, so that's why age will become a root value. So after age is student, and then okay, after student is credit rating. That's why. Okay, if you can see here, we divide the information into use first. Okay, we divide it into a use first, and then from the information we know that the income, okay, the student, credit rating, class, and etc. So the class for the use, we still have a no and also yes. Okay, and then when we divide it into a middle age, we found that the class, all of the middle age, the class is yes. Okay, and then for the senior, we have a yes and also no. Okay, that's why if you notice, we have a decision tree for bias computer from the age. Okay, so we have a youth, middle, and senior. For youth, because of we still have a class of yes and no, so that's why we need to use the information gain that we calculate earlier. Okay, so use the second highest is student, right? That's why we use a student. We use a student. So from student, we will categorize into no and also yes. If you notice, in the middle, for middle age, we put that as a yes. Because of what? Because of, as you can see in the circle, in the red circle, all the class is associated to yes. So you don't have to think more about it because the class associated to yes. So just put yes. But if the class you still have a yes and no, then you need to branch it. Okay. So the student we have a yes and no. We branch it into yes and no. After that, we use the credit rating. So the credit rating we also have yes, excellent, and also fair. Yes and no in order to form a decision tree. Okay. So rule extraction from a decision tree. Rules are easy to understand than large tree. One rule is created for each part from the root to a leaf. Each attribute value passed along a part forms a conjunction. Okay, ini just information that state that about the rule extraction from the decision tree. So that's why we use if then. If age equals to young, age equals to young, and student equals to no, then bias computer equals to no. This is the rules extraction from our bias computer decision tree. We extract the rules. Okay. For example, if age equals to middle, okay, if age equals to middle age, then by computer will be yes. Okay. So if age equals to old and credit rating equals to excellent, then by computer equals to yes. Okay. Computing information gain from continuous value attribute. Let attribute A be continuous. Okay. Must determine the best split point for A. So increasing order. Okay. Okay. You also need to find the information gain for continuous value attribute. And then I will pick a randomly who will present what's meant by information gain for continuous value attribute. Okay, you need to do it by yourself here and submit to me through a Google form. Google Classroom. So how to find the best split and etc. etc. Okay, so for the next class, I will pick one person to illustrate how to find the best split by using information again for continuous value attribute. So please be prepared and ready. Okay. So okay. After this presentation is for your additional information. So I don't think you need to know a lot. Okay. first thing first that you need to know is you need to know how to calculate this kind of split. Calculate this. So please do so. Okay, I want to give an example. Okay, the example given is for age, right? For age. So we have a age. Age. So use middle and also senior. For example, if you want to extract the box for income, okay. So I just put it here, income. Okay, for income. So as you can see, you need to divide the box. Okay, this is income. High, medium, low. Okay, and then maybe you need to tak nampak. Alamak, tak boleh guna. Okay, it's okay. Kalau tak nampak, let me show you. Okay, yeah. For example, here for income. For income. Okay, so this is box for income. So we have a P1. P1 is a buy, N1 is a not buy. And then you need to calculate the information again. Okay, so for income, we have a high income, medium income, and also low income. So from the tables, okay, you need to extract this table for income. P1, for example, we have two data that buy and also two data that not buy. Okay, for the medium income, we have four data that buy and two data is not buy. And then for the low income, we have 3%. Okay, 3% that who are buy and 1% who are don't buy. Okay, from that we know that we will get the data from the information gain for income. Okay, never mind, I will snap a picture and put it into WhatsApp group. Okay, so for example, you need to do like this to find an information gain. Yeah, information gain here. Information gain 2, so 2 over 4. Why 2 over 4? Because of the number of income that are high is only a 4%. So 2 over 4 that buy, okay, plus 2 over 4 that don't buy. So you will get the information gain here. Okay, never mind. I will put it in the group WhatsApp. Okay, so do you have any other question for this topic? I know that it's quite a lot of things that you need to understand. Okay, so please be there and please have a faith. Inshallah, I will assist you in order for you to know how to use the formula and etc. You can always PM me or text me if you don't understand about this kind of formula. Okay, so I want to open for the Q&A session. You have anything? No? Sure? Tak nampak. Okay, tak apa, yang tak nampak nanti I will snap picture. No sir. Okay, sure So kalau tak ada apa-apa, saya nak off record.